We've already gone over adding vectors and unit vector notation. Next, we're going to be talking about multiplying vectors. So we're going to talk about how to multiply a vector by a scalar. We're also going to learn about the dot product of vectors in magnitude angle notation and in unit vector notation. Uh, we're going to talk about the cross product of two vectors as well in magnitude angle and unit vector notations. And we're going to also briefly talk about the right-hand rule to find the direction of the vector that results from a cross product. So there's two different ways to multiply a vector by a vector. You can do something called a scalar product, which makes a scalar, or vector products, which makes a new vector. The scalar product of vectors for A and B is written A dot B. And this is just a formula that we have to know for A dot B. It's AB cosine psi, or you can write cosine theta. Doesn't really matter. This just has psi from the workbook here. So A is the magnitude of A, B is the magnitude of vector B, and psi is the angle between A and B. And the two angles can either be used. We can say psi or we can say psi minus 360. A is the vector itself, where we can say vector A has components AX, AY, and AZ. Same thing for B. A dot B on the left represents a scalar quantity. And we say this is the dot product A dot B. This also follows the commutative property with scalar products. So A dot B equals B dot A. All right, so multiplying vectors is not too bad when we multiply these. So we get A dot B, and we write out all of the components in unit vector notation for A, and then dot all the unit vector notation components for B with I hat, J hat, and K hat. And so we can then just multiply together the X components and the Y components and the Z components for these. So we don't use the distributive property. We just multiply the X components, Y components, and Z components together. The vector product is a little bit different. So the vector product is we say this is A cross B, and it is equal to C for the vector product is AB sine of psi, or AB sine theta, where psi is the smaller of the two angles between A and B, where here would be A and here would be B. And so psi is just the angle between those two lines, or those two vectors. And we call this the cross product. Is A cross B is one way we can say it. So if A and B are parallel, then A cross B equals 0. Or if they're in opposite directions, anti-parallel, then is A cross B is 0. The magnitude of A cross B, just like the magnitude of other numbers, we write with absolute value A cross B, and it reaches a maximum where A and B are perpendicular to each other. So the right-hand rule, we use the right-hand rule with vectors, and we also talk about it a bit later when we talk about rotational motion. It basically just has to do with which direction is the vector pointing. So you can do this by putting your hand on the table and determine what direction these vectors are going to be going. If you put your hand on the table and you say vector B is the straight line that's making a right angle with the table at the edge of the table, then vector A can be the other vector, and you can also use your hand to denote where the vector is going. But vector C is going to point upwards. And so that's how you can start to think about these vectors three-dimensionally. Vector C prime is equal to vector B cross vector A. Or another way to say it is vector C prime is equal to the negative of vector C. I think that's probably the easiest way to remember what that part is. And then also vector B times vector A, or excuse me, vector B cross vector A is the negative quantity of vector A cross vector B. All right, so when we multiply these vectors out in unit vector notation, when we multiply them with the cross products, it's a little bit different. So this time we do use the distributive property. And when we distribute this, what happens is when we get an I hat times I hat, that equals 0. So for our first term, we get ax I hat times bx I hat, and we can distribute, or we can factor out the ax bx, and now we're just left with I hat times I hat, and that equals 0. When we get ax I hat times byj hat, now we have ax component times by component, and we have I hat times j hat, or I hat cross j hat, I should say more specifically. And that makes k hat. So when we have I hat times j hat, that leaves us with a k hat. All right. I believe this next part is a proof, and this gets a little bit beyond the scope of what I would like to get into with this class. But this is a proof on how we would multiply these vectors. And that this says it's blocked here. This just says vector A cross vector B. But this is the formula for the vector product in unit vector notation. So the formula in green, you'll need to know that formula for completing these problems in the workbook. So we do need that formula, but the formula comes from matrices and finding the determinants of a matrix, and that's kind of beyond the scope of this class. If 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 you really want to know the proof of that, I would suggest looking up how to find determinants of matrices. Let's look at a sample problem. I think sample problems are always good to look at and examine rather than just looking at formulas and equations. It says, what is the angle psi between vector A if vector A is 3 I hat minus 4 j hat and vector B is negative 2 I hat plus 3 k hat? It says many of the following steps can be bypassed with a vector capable calculator, but we're not gonna use a vector calculator here. So we want to find the angle psi between vector A and vector B. And our formula for the dot product is A dot B is AB cosine psi, or AB cosine theta. And here I've written out everything from the X and the Y axis and the Z axis. And the Z axis is pointing in the upward direction. Just note that you can rotate this so that the Z axis is not pointing upward. You can rotate it so that the Y axis is pointing upward and the Z axis is pointing sort of at an angle close to toward you, but not quite. And again, we'll look at Desmos 3D graphing calculator is a great resource. You can just look up Desmos 3D graphing calculator, and it has this cube that you can see, and it's much more easy to see where all these values are. But I wanted to draw this out so that you could see how to solve these on paper. So A dot B is AB cosine psi. A is the length of vector A. And to find the actual length of vector A, we're just going to use the unit vector, we're going to use the vector components of X and Y, which is I hat and J hat, to find what vector A is. Now, I should have wrote an arrow over this A, technically. but this is the same formula, Pythagorean theorem formula that we used from earlier. And we don't really even have to do the Pythagorean theorem. We just know that vector A is x component of a squared plus y component of a squared. And then we add them together, find the square root, and we get that vector A is equal to 5. For B, we want to find the length of B. We have the unit vector notation there. So we write that B is equal to the square root of the x component of B squared plus the y component of B squared. And so we get 4 plus 9 is 13, and square root of 13 is about 3.61 for the B component. So all we've done so far is we found out what A is, that's the black line, and what B is, that's the blue line. Now, if we want to find the dot product, here's the formula for the dot product. So we write out all of the unit vector parts for A, dot all of the unit vector parts for B. And then we just are combining the i's with the i's and the j's with the j's. Actually, hang on just a moment here. That is not correct. We are using the distributive property here. So for the dot product, we're using the distributive property. So we're going to do 3.0 I hat times negative 2.0 I hat. That's the first one. That's here. I'll try to color code these. Negative or 3.0 I hat times 3.0 K hat. That's the second one. And we do the last two as well. So negative 4.0 J hat times negative 2.0 I hat and negative 4.0 J hat times 3.0 K hat. Sometimes PowerPoint deletes when I write, unfortunately. But that's okay. We'll continue going. So the distributive property, that's how we solve the dot product. Now, with dot products, the rule is a little bit different with I hats and J hats. So I hat times I hat with a dot product is equal to 1. Any of the same two are equal to 1 with a dot product. If it's I times J or J times K or K hat times I hat, these are all hat terminologies, then it is equal to 0. And this is for the dot product, not for the cross product. So for the dot product, we use the distributive property. And if we have two of the same hat components, they equal 1 when it's the dot a hat dot times another hat dot of the same variable, it equals 1. So A dot B, now after we expand all of this, so we have 1, 2, 3, 4 parts. First part's negative 6 I hat squared. Second one's 9 I hat K hat. Third one is 8 J hat I hat. Fourth one is negative 12 J hat K hat. Now our rule is 2 of the same variables multiplied equals 1. So the first one's negative 6 times 1. I hat K hat is equal to just 0. I should say I hat dot K hat is equal to 0. J hat I hat is equal to 0. J hat K hat is equal to 0. So we only have one term that we have to keep here. So now we know that A dot B is equal to negative 6. So we've done a few things so far. We found out what vector A is. We found out what vector B is. Then we found what A dot B is equal to. So now we can plug all that in to this formula here. So when we plug that in, we got A dot B is equal to negative 6. We're just going to put negative 6 over here on the left side. We found earlier that A is equal to 5 and B is equal to 3.61. All right. Now we're going to multiply these together. 5 times 3.61 is 18.05. And we're going to divide. We get cosine of psi is equal to -6 over 18.05. And then you can think of this as we take the inverse cosine of both sides, and we get psi is equal to inverse cosine -6 over 18.05. And we finally get a answer for psi of 109.42 degrees. All right, so a lot of steps to do there. Let me go back and we'll just kind of review what we did again one more time. So for A, I was a bit mistaken earlier. I said I was supposed to put arrows over here and make this a vector A. That's not true. A is the length of A. So I was mistaken about that part. A is the length of A, and B is the length of B. So it's just one component of vector B. It's just the, you can think of it as just the magnitude of B, not necessarily the magnitude and direction. So it's not the whole vector. But once we find A and B, then we find the dot product of A dot B. And we write the vector notations in unit vector notation. And we do the dot product. The dot product is when we use distributive property. All right, this next one is using the cross product now. So it says in this figure, vector A lies on the XY plane. It has a magnitude of 18 units and it points in a direction of 250 degrees from the positive direction of the x-axis. Also, vector B has a magnitude of 12 units and it points in the positive direction of the z-axis. What is the vector product C equals A cross B? All right, so there's a lot going on here in this diagram. We want to figure out what this result is. It says, what is the vector product C equals A, vector A cross vector B? So we do know one thing. We know that psi is equal to 90 degrees because A and B are perpendicular. And we can see that from our diagram here. Double check some stuff here. Okay. So because it's perpendicular, psi is 90 degrees from A and B. So this part is what 90 degrees is. Actually, I didn't quite draw that along with the 90 degrees there. This part is 90 degrees. All right, so those are both perpendicular. A and B are not in unit vector notation, so we have to use the equation. Let's see what else other information that it gave us here. So it said that A has a magnitude of 18 and it's 250 degrees from the positive direction of the x-axis. Okay, so from the positive direction of the x-axis, so it's sweeping over this way and it's landing here, and that's where vector A is going to be. Vector B has a magnitude of 12 units and it's pointing in the positive direction of the z-axis, so it's going up that way. All right, so now we're just going to plug in these values into our formula. So it tells us already the magnitude. So the magnitude of vector A is just what A is, and that's 18. And the magnitude of vector B tells us that it's 12. And psi is just 90. So it told us that as well. It's just 90. So the magnitude of vector C is 216. And because it's perpendicular to the direction of A, we can now figure out the angle of this. So the direction of C is perpendicular to the direction of A. All right. So We know that A is at 250 and it's perpendicular to A, so we can subtract that 90 degrees and we get 160 degrees from here to here is how much that it sweeps out from the x-axis. All right, one more problem to go. We're going to use this formula. I know it's a little tough to see this. This says vector A cross vector B at the bottom. If vector A equals 3i hat minus 4j hat and vector B equals negative 2i hat plus 3k hat, what is vector C equals vector A cross vector B? So let's write what we know so far. We know the x component for A, we know the y component for A, we know the z component for A. And those correspond to I hat, j hat, and k hat. There is no z component for A. I'm trying to find the mouse here so I can point a little bit better. Let's see why it's not showing up. Here we go. Let's try that. Okay, so here's x component, y component, and there's no k for vector A. So there's actually az is 0 for the z component for A. For vector B, x component is -2. The y component is 0. It skips j. It goes right to k. So by is 0. bz is 3. So now we're going to write this out all as one statement. So if we're going to add these together, so this becomes, actually, we're not adding them together, excuse me. We are using this formula down here. So this is the formula for the cross product of vector A cross vector B. And again, the proof is very complex. Just use the formula here and you should be just fine for cross products. So AY is -4. Z component of B is 3. And we're just plugging in all these numbers and we get -12 I hat plus -9 j hat minus 8 k hat. And so that's how we would write that in unit vector notation for the cross product. So again, just remember to use this formula. Apologies that this got a little bit cut off here with the screen share, but this says A vector A cross vector B. And here's the bookwork for this section.